Hi everyone. In this video, we will see what are vectors, what are embedding models, and what are vector databases. Then we will see what is Pinecone vector database and how to use it. And then we will see what is similarity search and how it's used in retrieval augmented generation. So let's start with vectors. Vectors we can consider as list of number. It can be one number or more than one number. And then we have dimension of vector. So dimension of vector is nothing, it's just the number of elements in that vector. So for example, here dimension would be 3, here dimension would be 2, and here we have 7 elements, so dimension will be 7. Now there is another important concept which we should understand is similarity of vectors, which is used in similarity search in vector databases. So here consider this vector as a two-dimensional vector in xy plane. Then we can clearly see that this vector is more similar to these two vectors as compared to these. And we are saying this on the fact that distance between this and this vector 1 1 and 2 1 vector is less as compared to distance between 1 1 and 7 6. So this is called geometric similarity, which we are seeing in xy plane. Now in case of embedding models, we do not use this two-dimensional plane. There we use multi-dimensional plane, like we use multiple dimensional vector, for Hugging Face, dimension of vectors is 384, and for OpenAI dimension is 1536. So there we use cosine similarity and Euclidean distance to find vectors similar to our query vector. So cosine similarity measures cosine of angle between two vectors, and Euclidean is another method which is used. And we do not need to worry much about this because these things are abstracted for us, and we have to just select which method we use and we want to use, and that is handled automatically by, in this case, Pinecone will automatically take care. Now we know what are vectors. Let's see what are embeddings. So embedding we can think of as this. Suppose this is embedding model, then we can think it as black box which takes either text or words or phrases as input and then convert those as this vector. And dimension of this vector will depend on which model we choose to convert. And while converting from text to vector, it makes sure that vectors with similar semantical meaning are vectors with similar semantic meanings are placed close together. So for example, I can go to this site and I can copy it. It's not selected. Yeah, not selected. So I will go to visualization and here I will paste whatever I copied from there. Looks like it not copied. Okay, so now I have some words like dog, cat, mouse, and then tiger, lion, cheetah, lizard, superman, and leopard. Now if I use, suppose I use these three models and visualize them. So what it will do is that it will group together words which have similar semantic meaning. So here this model is trained on Wikipedia data, and it categorized cow, dog, and cat together, and then these cheetah, leopard, lion, tiger, these are more of wild animal and also belong to cat family. So these are categorized as here, and wolf is kept separate because it's wild animal, but it not falls in category of this cat family. And then we have lizard as separate, which is different from this. So that's how we can see that how words with similar semantic meanings are grouped together. But different model do things differently because this the model which is trained on data from Google News, it does in bit different manner, and something is English gigaword on this model which is trained on this. It also does similar organization, but things are not clustered in all models in same way. So now we know that embedding is a vector or list of floating numbers, and the distance between two vector measures their relatedness, how much they are related, and small distance suggests that they are highly related, and large distance suggests that they are low related. Similar to this, we can clearly see that lizard and tiger are low related or less related as compared to tiger and lion. Now we have embeddings which take text and convert it to vector, and we can either use OpenAI or Hugging Face. So now let's see how embeddings work. So I will go to this Hugging Face link, and this document describes what are embeddings and also gives one example. So as embedding model, it's using this one called all-MiniLM L6v2. We will also use this. We will just follow this tutorial and convert these sentences to vector using this embedding model. So first thing is that we need to install this. I will copy it. And in terminal, paste, and I will do pip env install sentence transformer. Since it's already installed for me, it happened quickly. Now after that, let's copy this whole thing. So from sentence transformer, we are importing sentence transformer, and then we are creating instance of embedding model named this one. And then we are creating one list. And in this list, we have 3 sentences. Now we can call this model.encode, and then we can pass list of sentence to convert our sentence into vector. And then we are just iterating through output and printing it. Also here in print, let's add one more print, and let's call dimension. So we will also print dimension of embeddings which we are getting from dimension of vectors which we are getting from this embedding model. I will do length of embedding, and let's clear here and run it. So it created 3 big vectors. For first sentence, this framework generates embedding this one. It created this vector, and here its dimension is 384. Similar for second sentence, and similar for third sentence. I think I clicked 2 times, so it did same thing 2 times. But yeah. So this is how embeddings work. It's just easy. We just need to pass our sentence or text, and everything will be taken care by whatever library we will use. Now we have vectors, and we have embedding model which convert our text to vector. Now we need some place where we can store our vector and efficiently do operation on that storage. There we have vector databases. So vector databases are used to efficiently store and do operation on vector. So here we have some kinds of databases. We have MySQL database, which is used to store tabular data or more structured data. Then we have MongoDB, which stores key value pairs. And then we have graph DBs, which store graph data. One example is AWS Neptune. And then we have this new kind of DB, which is called vector database. And as we can see, it just stores vectors and also allow to efficiently do operations like similarity search in this vector database, in this database. And two famous vector databases are Pinecone and Chroma. There is one more from Meta, which is in-memory vector database, and that's also open source. Now we have similarity search. So if I open it, yeah. So now suppose this is just a representation of vectors in some higher dimension, and suppose we have some query, our own query. Let's call it dog. So what we can do now, we have this lot of data which is in form of vector and it's stored in VectorDB. Suppose it's stored in Pinecone DB, and now we want to find dog information which is related to dog. And if we can successfully find vectors which are related to this dog word, then we can get some context related to dog. So what we can do is we can convert our query to vector. Suppose we only just use this. Okay. Suppose I convert this dog to big vector like this using some embedding model. Generally, I will use same embedding model which I use to create these vectors, and then I can search that where this vector belongs. So suppose this to search and it finds that it's belong here. So what VectorDB will do that it will take out all this data, all these vectors which are similar to our vector, and then give us as output. Now its application is famous application is this one, Retrieval augmented generation. So what happens here is that we have some query, then we convert that query to vector, and then we perform similarity search. And once we get similarity search, we get similar vectors. Then we convert those similar vectors back to normal text. Then in LLM model, we pass our whatever was query, like our query was what cat prefers to eat. So that will be query. Prompt, suppose any prompt we have which we want to pass to LLM, and context. So in our database, we are storing vectors regarding cat, gardening, and cooking. And when we do similarity search, then all data related to cat or some part of data related to cat will be taken out, and that will be converted to text and feed it to LLM model. Based on that context, our LLM model can give us answer. Suppose it got some data related to cat and it gave answer that cat prefer to eat cat food. So that's how this retrieval augmented generation work. You can also go through this link. So we'll open it in new tab. So if we see same thing here, from user we get prompt and query. Then we take query and then we search relevant information in here is normal knowledge base, but we do similarity search in vector databases. And then once we get relevant information, we convert it to normal text form. And then we can feed same information to this query prompt and enhanced text. Third step is relevant information for enhanced context. Okay. And then we can feed this prompt query and whatever information we got from database to LLM model, and then it will generate some output based on our query prompt and context which we passed. So this is a common application, and this is useful if you want to chat with your PDF. Suppose you have big PDF document, then first step is what you can do. You can store whole PDF in this database, vector database, and then you can ask questions, and those questions will be these queries which will go through all this process and finally give you answer related to your question. We will do this thing in next video. For now, let's see what is Pinecone and how to use it. So we will just create simple database in Pinecone and we'll do similarity search. We'll close all these tabs. And here Pinecone database. So I am already logged in, and this is free account. First thing we need is API keys. So you can go to API key section, copy your API key and region. Then you can come to your environment file. I'm showing env example. You can go to your actual .env file and add two new variables. First is Pinecone API key. You paste your API key here. And in Pinecone region, in our case, in my case, it's US West 1 GCP free. So just paste it as it is. And that's what required for environment setup. Now let's create our first Pinecone database. So for that, I will go to indexes, and in MySQL database, we have tables. Similarly, we have index here in Pinecone. So I will hit on create index and name, let's call it demo, and dimension. So dimension, as we discussed earlier, each embedding model have its own preference of dimension. For OpenAI, it's 1536. For the Hugging Face one, it's 384. For this example, I will use Hugging Face, so I will keep 384. And this is the metric which we talked about initially, which is used to find similar vectors. So let's keep it cosine. And this is free account, so I have I can't select these things. It's already selected as starter, and I can click on create index. So it's initializing the index. Now let's go to our VS Code and write Python file to upload these vectors. Whatever vectors we created in main.py, we will upload these vectors to database. So let's create Pinecone demo.py. First thing I will import, but before importing, I had already done, but you need to do pip env install Pinecone client. I will just quickly show pip-env file, not pip-env, pip file, so that we are in this tutorial we installed sentence transformer and Pinecone client. So I will import Pinecone, and then index. But before that, I need to initialize Pinecone. So If you click on this connect button, it will give you instructions and link to documentation. In my case, I had already installed, and this is the code to initialize Pinecone. So let's do pinecone.init. I think it's capital P. It's a small p only. Pinecone. Pinecone is not assessed. Let's see what's wrong. Okay, it's not assessed. Pinecone.init, and here we need to pass API key, and after that region. So common environment. Environment is nothing but region. Now we had already kept these things in our env file. So let's load using from .env, import load.env, and let's do load.env, and also let's at the top I will import OS. It's giving error. So with the help of OS, now I can do os.get env, and it's in my env is already loaded because of .env, so I can just do not OpenAI. It's Pinecone API key. So Pinecone API key, and same for environment, os.get env, and here Pinecone region. Now let's create index. So index equals pinecone.index, and the index which we created was demo. And then let's print out, or let's store as response, index.describe index status. This method will return information related to our index which we created. I will just print the response. Also, this will make sure that we had initialized correctly. So it returned information regarding our index. Dimension is 384, and currently we had not stored any vector. So let's go and store some vectors. Right now it's 0 vector. So to store or upload vectors to this Pinecone VectorDB, we use Upsert method. And if I go here, then this is the format which it expects to upload. So for each vector, it expects that we will provide ID, and it expects that vector will be in this list. So I will just copy paste old code which we use to create embeddings. Then I go from here to here. Now we don't need these two lines. I will comment them out and paste it. So what we are doing, we are imported embedding model, and we are passing these sentences, and then we are getting embedding. But this embedding which is returned is in form of array. So let's convert it into list. To which method of Python will handle it. Now we had already created index instance of index. Let's just upsert our vectors. So I will do index.upsert, and values, or not values, vectors. And in vectors I can't directly do like vectors equals embedding because it accepts ID also. So I will do zip and then ID and then vectors. Not vectors, we had kept embedding, so embeddings. And we already know that we will pass three vectors here. So I will create three ID. First, let's call 1, 2, 3, but it will accept only string or character, so it will not accept number. Done. Now I will run this command, and also after running this command, let's print out status of our index. Okay, so it uploaded vector for these three sentences, and now we can see that total vector count is 3. Here also, if I go top, then now we have 3 vectors. Now we created, we use embedding model to convert our text data to vector and successfully uploaded vectors to VectorDB. Now let's do search operation. So I will call Similarity search.py, and here I need till here. Also I need this. Yes, I think I need all. Let's copy all. Paste it, and now let's do similarity search. For that, I will remove this part. So we stored these 3 sentences, and now I want to do queries, something related to, let's say, dog. So what I want is that out of these 3 vectors, return me vector which matches to my query. So for that, suppose I have query as dog. Now I can't directly go and say that which vector matches to dog. I first need to convert this vector, this word to vector. So for that, I will use same model which we used in previous code. I will remove this part, also not required. And here in sentences, it accepts array. So I will pass array or list, or here I will do dog. Now this will convert our dog to vector, and now let's call Pinecone to search for this vector. So I can do response equals index dot query, and index dot query accept queries, and queries is nothing, just list of vectors, which list of vector, or we can call query vector, and then we can pass how many results we want. We want only one array which is matching the only one vector which is matching most, or we want 2, 3 or more, and then we can also pass if we want to include data and metadata or not. So let's start queries. Our query is embeddings, or instead of embedding, let's call it query vector. Query vector. Here also I will pass query vector, and then we need to pass how many results we want. So let's pass 3, because we know in our database we have 3 vectors, and include values. So if we want the value of vector or not. For now, let's keep it false, and print out response, clear the terminal, and run it. So we got the results, and in result we have these matches, and it also contained list, and it returned three elements in this list because we kept that we want three, and array with not array vector with ID 3 has maximum matching score. Other two vectors have little bit less, and we already know that the vector which have dog in it is third one. Now let's keep it top one. I want top one only, and let's keep it true and run again. So this time, along with score, it will also return what is the value of that vector. Now, okay, it's done. So this is the value of vector, and it's total 384 numbers, and also it returned the score. Now we can use it here. So we are at this number 6 step. Our database returned context or vector which matches our query vector, and then we can again pass it through embedding model to decode. Right now it's form of vector. We can again convert it to sentence, and then we can pass sentence which is context and our query and our prompt to LLM model, and LLM according to the prompt, LLM model will give us the output. So this is what for this video. To summarize, first we saw what are vectors, and then we saw how embedding model works and how they convert text data to vector data, and then we saw what are VectorDB, how they store data in it, and we then saw how to create VectorDB, how to store data in VectorDB, and how to do similarity search. And we also saw one useful case of similarity search, which is retrieval augmented generation. So yeah, that's all for this video. If you have any question, do let me know in the comments. Thanks for watching.